Good morning, sir. I'm going to take a short seminar on the topic isolation amplifier. Isolation amplifier is used mainly to reduce the common voltage between the amplifier side and the power source side. And to separate these two components, we are using an isolation amplifier. That's the basic function, and that is where we are using isolation amplifier. Now, going deeply into it, isolation amplifiers provide electrical isolation. As I told you, it produces electrical isolation and an electrical safety barrier. It does not allow, or it does not provide direct connection between the power source side and the amplifier side. So since if there is a direct connection between these two sides, and there will be a huge potential, so that it makes a huge possibility of a huge current to flow through the amplifier, which may damage the amplifier. So that is the objective, or that is the purpose of using isolation amplifiers. They protect the operators from leakage currents. If in the power source side, for example, if an operator is using means it avoids leakage currents to flow through the circuit, since it is being isolated. Now they break the ohmic continuity of electrical signals between input and output. Ohmic continuity, it provides impedance like infinite values, or like large impedance values. So electrical signals cannot as directly pass through between from the power source and the amplifier as in a continuous manner. So it provides infinite ohmic continuity. Then insulated power supplies are provided for both the input and output stages. Since these both are being separated, these two parts has to be given an insulated power supply. Normally DC to DC converters will be used, and used in both sides, and isolated power supplies will be given. Used to amplify low level signals. Obviously it can only handle only low level signals, and it is being used particularly in places where low level signals are being used. For example, ECG, electrocardiogram signals, and applications like that. Now, pin configuration. Pin configuration is that you will have one voltage divider, and it will be provided to the isolation amplifier. Like this is the symbol of the isolation amplifier, and these 2 points are 2 grounds with the 2 outputs, V out P and V out N, like phase and neutral. And since you can notice from here, this is the power source part, and this is the amplifier part. So it is being divided by this. It is being shown that it has been divided. Amplifier will be in a triangular shape, but a cut between these two implies that it is being divided. Now, types of isolation amplifiers are transformer isolation, optical isolation, and capacitive isolation. Generally, depending on the application and depending on the budget of the application, we can use you can choose even these three isolation methods. Generally, in low level applications, transformers will be used, but in transformers, noises will be a major problem. And in high power, or in high sensitive applications, or in highly in places where if electromagnetic signal is used, there is a possibility such that these electromagnetic signals will get disturbed. In that cases, optical isolation methods will be used. And capacitive isolation, which consumes huge part of the system, or like it can make the system so much expensive, and changing the capacitors according to the application or according to the output we want is much difficult than these two inputs. Now, taking into the first method or first type of isolation amplifiers, this is the most common and can be easily used, which is transformer coupled. Like this is the general circuit diagram of transformer coupled device, and this is an isolating amplifier. Means it is an arrangement of two operational amplifiers and transformer and rectifier and oscillator and power supply. The whole circuit is known as isolation amplifier. Now, if you see from here, the primary voltage HT minus HT. The primary voltage is being divided, or it is these resistors or impedances are being used to give bias to the operational amplifier. From this operational amplifier, the single ended amplifier is being connected as output to this operational amplifier. Now, if you see here, a rectifier is being used, which converts AC signal to a DC signal and provides to as power supply to this operational and isolating amplifier. Now, this transformer will be placed over here, or it is being given as a representative of the part which has to be here. This transformer, if you see here, because of this transformer, there will be no direct connection between this primary part and this secondary part. There is no direct connection. It depends on the transformer function. If the current passing through the primary winding is like a particular value, the corresponding magnetic flux will be developed in the transformer, and that magnetic flux will be engaged with the secondary winding, and from the secondary winding the current will be appropriately produced. That is the basic function of a transformer. And if you note here, this transformer is like not like a step down or step up transformer. It is generally an isolating transformer. It only isolates this primary part and the secondary part. It does not amplify any voltage or current. So, coming to the secondary side, we have one secondary amplifier, and this oscillator. This oscillator produces or excites with this power supply and is used to energize these secondary amplifiers. This operational amplifier is a single-ended amplifier which is connected to the isolating amplifier, and this single-ended output is being taken as the output. If you see here, as I have told you, this plus HT and minus HT is a separate DC source, and this plus VC and minus VC is separate DC source. So we have two separate DC source which energizes two separate parts, as shown here, primary part and the secondary part, which is being separated by this transformer. So now this is the basic principle of the separation of primary part and the secondary part. If we connect simply by means of a wire instead of this transformer, we will be getting a direct connection between these two parts. So if you are seeing like this, there will be a huge potential difference between these two parts, which makes a a huge possibility of huge current to pass through this part. Hence, a separation between these two avoids this flow of large current. As I told you, it uses either a frequency modulator or phase width modulator carrier signal. Internally, it has 20 kHz oscillator. Okay, it uses either frequency modulator or pulse width modulator carrier signal. Internally, it has a 20 kHz oscillator, transformer, filter, and a rectifier to provide supplies for each isolated stages. As I told you, the oscillator and the rectifier provides some power supply separately to these two parts. Rectifier, input to primary op-amp. The rectifier provides input to the primary op-amp. Oscillator provides inputs to the secondary op-amp. Then transformer couples the supply. Then a low-pass filter is used to remove the other frequency components. The output of this signal can be passed to a low-pass filter, which separates the low frequency or separates the high frequency noises and makes the signal pure. Advantages: high common mode rejection ratio. Common mode rejection ratio is the ability to reject other frequency signals. It will be having one band of signals to pass through. If the coming signal or the input signal is other than or away from, is not in the range of this band frequency signal, then it will be rejected. The ability to detect and reject these kind of signals is known as common mode rejection ratio. The common mode rejection ratio for this signal is for this amplifier is very high. The high linearity, output produced is of linear in nature. Then high accuracy. Accuracy will be more since it is being isolated. No noises can exit the transformer as easily, and high accuracy will be possible by using amplifiers and signal conditioners. Then applications: in medical, industrial, and nuclear. These isolation amplifiers are being used. In medical purpose, for what you use? If you are considering instrumentation devices like ECG, then air breathers, and that it will work based on the signals which are very feeble. In that cases, the amount of the disturbance of noises will be more. To avoid that, they will be using these isolation amplifiers. Or if the patient is being connected, there are various instruments where patient body will be connected to the patient body parts will be connected to the instruments. In that case, if a high frequency voltage or a high voltage spike is being is affecting the instruments, then it will affect directly the person. So to avoid these conditions, in medical purposes, they are using this isolation amplifiers. In industrial purposes, ground loop elimination and off-ground signal measurement. Ground loop elimination. Now, if it is being connected, the amplifier part and the signal part is being connected to the same ground voltage, then connected to the same ground, then it will be having a ground loop currents. These loop currents can be as high as possible, so that it will disturb the patient. It will give shock, like it will give current shock to the patient. Or if machines are being used in industrial processes, it will give much effect of the magnetic effect, magnetic calculations of the machine. The nuclear output power isolation. Input power in particular devices where nuclear where sensitive instruments are being used. Obviously, these isolation amplifiers will be used as part of safety measures. Then in medical, as I told you, this patient body parts is connected to patient signal amplifiers, and it is being amplified by using a transformer. This transformer is being excited by an electrical circuit, which this transformer gives output to this electrical circuit, and this electrical circuit is conditioning the signal and is giving to this transformer, mains transformer. This transformer is being excited. This transformer is being excited by the power supply which we are giving, this transformer provides signal to this transformer. Now from the shield is being given to this circuit, which is connected to the instrument case as a ground circuit. Now from this ground circuit and the body, connections are taken to the patient's ground driven to 0 by amplifier, and it is given to the output as the patient, output to the patient. This is how in medical purposes which we are using. Now if the patient signal will be amplified by this transformer, not amplified, will be amplified by this signal amplifiers. It will be given to the primary winding of this transformer. The secondary winding of the transformer takes the signal and is given to the electrical circuit. This electrical circuit is being excited by this transformer, mains transformer, which receives power supply from this LN points, and this point is given is for an internal shield, and this is for an instrument case. So these two points are being connected, and the patient is given a 0 ground amplifier by using this. Now optically isolated transformer. In optically isolated transformer, the thing is that you are passing the signal in optical manner. That is the difference between these two isolated amplifiers. If you see here, an encoder is being used, which gives signal to the LED driver. The LED produces signals to this photodiode. The photodiode takes the signal to the decoder. Decoder takes signal to this common point. From this point, it is being taken to LED driver again, and which produces signals to this photodiode, which this clock detector, according to the signal from this photodiode, clock signals will be produced to the encoder. That is the basic function of this circuit. And then the biological signal is converted into light signal by LED for further processing. Biological signal here will be converted as electrical signal here. It has patient circuit, which is the input circuit, and photo transistor forms the output circuit. This is the input circuit, this is the input circuit, and this is the output circuit. Each circuit is battery driven, and the input circuit converts the signal to light, and the output circuit converts the light back to signal. Input circuit converts the light to a signal, which decodes everything, calculates the parameters of patient, and is given to this LED. The LED the corrections or the signals which has to be given to the encoder is being given by this LED to this photodiode, which produces signal to the encoder. Now the advantages of original frequency and amplitude is obtained. High linearity, as per as the same as transformer coupled isolation amplifier, it can produce high linearity. No modulator or demodulator is needed as it couples optically. Modulator or demodulator is not needed. If this information signal is a electromagnetic signal, you can use carrier amplifier and you can transmit to long distances. Since the signal is optical signal, you don't need a modulator or a demodulator. Improves patient safety. Since the signal, it even improves the safety signal, since the signal is being optical, it is not electronics, electrical signal, so it further improves the patient's safety. Now the applications. Since optical isolation is a high sensitive isolation amplifier, it will be used in many industrial purposes in data acquisition systems, since the signals should be of highly precise signal. Then interface element, then two interfaces element as we have seen now. Then biomedical measurements, patient monitoring, test equipment can be used to test equipment, current transmission, ground loop element to eliminate ground loops, and for SCR controls. Like SCR, you will be controlling using light triggering methods. In that methods you can use this. This is the circuit of this is the circuit of isolated optical isolated mechanism which will be used in patient monitoring. And if you see here the points where the circuit is being connected to the patient is given to as differential amplifier. This R1 and R2 is used for biasing this amplifier, and this R3 is used as feedback. It is given to the transistor. The transistor has a power supply plus relay, which is being biased by an R6. Now the photodiode is being biased by using this R7. The photodiode converts this signal by using the power supply from the differential amplifier, and which gives to the optical isolator, which gives to the phototransistor. Now the phototransistor by the biasing resistors, when the signal is greater than the biasing voltage, it will conduct signal from plus B to the ground. That's the ECG output is being obtained. Capacitive and coupled amplifier. Capacitive coupled amplifier uses basically its capacitive action as a barrier to the circuit. Now if you see here, the analog in circuit, analog in signal has been converted to given to a modulator, which gives to an isolation, which is capacitor, and this isolator from this circuit is given to a demodulator, and from the demodulator the analog output is being taken. If you see here, it will be mainly used for digital encoding of the signal, and the input voltage is converted to a proportional charge and is being stored on a capacitor. It has both modulator and demodulator circuits, since the signal is electrical signal. Modulator and demodulator circuits, the circuit uses like differential capacitor, which is differential capacitor, in which the capacitive voltage of the capacitor provides the isolation. Obviously, since there is an isolation amplifier, the demodulator and modulator parts will be given separate DC to DC converters, and will be given separate, and then the output signal will be taken. ripple noises are removed. Okay, since capacitors are used, the ripple noises is removed. It avoids device noise, radiator noise, and conductor noise. High immunity to magnetic noises. Since capacitor blocks DC, magnetic noises will be avoided. Useful for analog systems, since DC signals will be blocked, has high gain, stability, and linearity. It is being used in data acquisition, interface, element and patient monitoring, ECG, and EEG. Comparative study. If you study these isolation amplifiers, you can, according to some criteria, you will find that these isolation amplifiers will be used in particular applications according to the various parameters. What are the parameters and how are they differentiated? Now the cost. First thing is cost. Cost is like optical thing will be low cost due to less components. It involves only low electronic components. And then transformer, cost of the transformer and the accessories is more. Hence the transformer, usage of transformer will be more robust, because you can use this transformer oscillator amplifier. And then capacitor coupled high cost amplifier. Since capacitor, the cost of the capacitor is more according to the voltage it can hold. Oscillation voltage. Voltage, what it can handle. Optical can handle low. It can handle only 800 volts. Since the light is being a major signal. Then transformer, then capacitors. Capacitance, you can increase the capacitor action according to the capacitance for capacitors variation. Then optical isolation resistances. Optical 10⁻12 resistance it produces. Transformer 10⁻10. Obviously, since it isolates by using magnetic flux, and hence there will be limitation to its ohmic resistances. And capacitance 10⁻12. Gain, stability, and linearity. Optical, transformer, and capacitance. Optical will be 0.02 gain, percent gain. Transformer between 0.05 and 0.02, and capacitance 0.005 rest. Rest will be obtained by this capacitance. So if you want more gain, if you want more linear output, you can use capacitance oscillation. Thank you.